Hello everyone, welcome back to another video. So in this video, we're going to continue with our series on building GraphRAG systems from A to Z, right? So this is the fourth video in the series. In this video, we're going to go ahead and learn how to convert natural language into ciphertext. So basically, this is what you're trying to do. Let me just go ahead and just give you an overview of what the whole series is about, what you have done so far. In case any of you is new here and you want to catch up, you can simply get a log. So basically, we built take a CSV file, which is the Northwind trade data set. We're able to inject the CSV file into a knowledge graph. It's basically a data graph. Manually, we did the manual process, right? Writing some kind of like Python scripts to do that for us. And then we went ahead and built an ETL pipeline. And then we learned the basics of LangChain, which is going to be the LLM orchestration framework that is going to help us to build our RAG system on top of basically our RAG graph system. And then from there, now we are in video number 4, which we're going to go ahead and learn how to convert natural language into cipher code. Okay, so basically what are we trying to do in this part of the series, which is video number 4? Basically, let's say a user asks a question, right? We take that user question, which is in natural language, and we convert this natural language, this natural language. By natural language, I mean any human language, like in English or in Spanish or something like that, right? So user asks a question, you're going to take that question of the user, convert that question into cipher code using AI. AI is going to do that for us. Once you convert the code into cipher code, you're going to execute the cipher code against our Neo4j database, retrieve the relevant information and use that relevant information, pass it back to the LLM, and the LLM can use it to answer a question, right? So this is what we're going to be covering in this video. So we're going to go ahead and learn how to create embeddings to enrich our knowledge graph. We're going to learn how to perform similarity searches using metadata filters and a whole of other things of perform similarity searches. You're going to go ahead and using different operators that you can use to perform filtering. You're going to go ahead and then build a basic chatbot. So if you are so eager from the beginning of the series on when you're going to be building a chatbot, now we are finally here, right? So all the boring stuff, I know it's just not very kind of engaging because most people probably watch because you want to build a chatbot, right? But sometimes you just have to do the dirty work first. So yeah, in this case, you're going to go ahead and learn how to build a very basic chatbot. And then from there, you're going to go ahead and convert them and then write basically a script that is going to help take in natural language, which is the user question, use this user question into cipher code, right? And then execute the cipher code, get relevant information, and can answer the user's question. Okay, that's what you're going to be doing in this video. Okay, so basically the user asks a question. So let's say this is Johnny right here, little Johnny. Little Johnny asks a question which is in natural language, let's say English. That English, which is natural language, is converted into cipher code, which is the programming language that Neo4j can understand, right? Once it has that cipher code, you're going to execute it to retrieve the relevant information or documents, and that's going to be passed to the LLM, and from there, the LLM can go ahead and generate a response, which is going to be sent back to little Johnny. Basically, that's what you're trying to do in this video, okay? Okay. So these are the things that we'll be covering: building a Neo4j knowledge graph, performing similarity search with metadata filters, performing similarity search with operators, building a chatbot, using natural language into Cypher. We're going to go ahead and learn a bit of risk of why this is has a risk, right? Because there's something called a prompt injection, and the prompt injection can be used by hackers to affect your system. We'll look at what exactly is that. We'll take a short look at what is a few short prompting, and then finally we go ahead and test our final chatbot to make sure it works as we expect it to. Okay, that's all we're going to be covering in this video. So let's jump into it. So the first we're going to be going ahead and cover is building a vector chain in Neo4j. So I was really thinking, what's the easiest way to explain a vector chain to someone? Because when I was basically learning what vector chain was, a vector index, right? I was like, I didn't really get this right. So I used Claude and I just asked a bit of questions about what is a vector store or a vector index. I asked it to explain it to me like I was seeing grade 1 or grade level 1. And this is what it outputted. So you can pause the video and just read through. But you can also read through it together. So let's see what it has to say. So a vector index is like a a toy box that helps you find your favorite toys very quickly. Imagine you have a big toy box with lots of different toys. First, we give each toy a special tag that tells us what it looks like, right? Then we put toys that look alike close to each other in a box, right? So all the things that are close to each other, we put them in one location, right? That's one very important point of understanding what a vector index is or a vector store is. So when you want to find a toy, you just tell the box what kind of toy you want. The box knows where to look for and find your toy very fast, because all the toys have been grouped together and now classified into different sections, right? So it's like having a magic helper that always knows where your toys are. So if you don't have to search through the whole box, every time, because it has an idea of basically where everything is. So whenever you're searching for something, the search is much faster than when it doesn't know where things are in the box, right? Where the different toys are. So this special box toy, which is a vector index, helps computers find things very quickly, just like it helps you find your toy in this specific case. So that's what basically a vector index is. It's just a way of storing information within computer systems that it can be retrieved and searched through or queried very quickly. That's basically it. Okay. So these are some useful links. Okay, this what I've explained might not make really deep sense to a lot of people, because I didn't want this to, like, explaining a vector index on its own is gonna be like a whole series on its own, right? So I'm just trying to give you a basic idea of what really a vector store is. So if you really don't understand it, that's all fine. I have some links here. You can always follow these links and read more about the vector, what a vector store is. I think I'll just create a link and share these slides that I'm using so that you guys can have access to these slides and be able to access these different links. Okay. So basically, the user asks a question. Little Johnny asks a question, which is a user query. We perform a similarity search to retrieve the most similar matching documents. Like, right, you retrieve the document that can be that has more similarity to the question that Little Johnny asked, and then those retrieved documents or the relevant documents are passed to the LLM, and the LLM generates a response based on that. So answers is more grounded, because you're not answering the facts, the answer, you're not answering or generating an answer based on what the LM has been trained on. We're generating an answer using our own custom data, grounding the answer. So we're basically grounding the LLM to a given set of documents, right? So the answer is more relevant and more understandable. Okay, so that's basically what the whole system of how RAG works in on a surface level, right? So now we are in the search, we are in the part we're performing a similarity search, and let's go ahead and first create a vector index, and then from the vector index we can go ahead and perform a similarity search. So first we'll need to create an index, right? Instead of this index, we can specify different node properties we'll like to create an embeddings on. So basically you have whenever I read that part I will show, basically we just specify a lot of embeddings, a lot of properties that we want to create embeddings on, right? The embeddings will be created using, we're going to use OpenAI embeddings. We're going to use the OpenAI embedding models. You can read more about the embedding models. I'm going to keep a link right here, which is the first link right there, OpenAI embedding models. Okay. You can also use other or other open source models if you wish to, but in this case, I'm going to be using OpenAI embedding models. Okay. When a user passes in a query, perform a similarity search. And if you know what a similarity search is, again, I have another link right here. Basically, uses a vector index and a user query to find the most similar document that can be used to answer the user question. That's what a similarity search is on a surface level, like in a layman's term. If you want to read more, I have this link right. You can go ahead and read more about what a similarity search basically goes into. Things like cosine similarity and KNN and all those things, right? That's a whole different topic on its own. So it uses similarity search to find the most relevant document that can be used to answer the user's question. That the information that is more relevant are now are called the retrieved document and are sent to LLM, and the LLM can generate an answer based on those retrieved documents. So that's basically it on the surface level. Now let's jump into the code. Okay, so you're going to be using the file from last time right here. I have it right here. So you're going to go ahead and import a couple of things, right? So you're going to go ahead and import OS. Also going to go ahead and import, you're going to say from LangChain underscore OpenAI. I'm going to go ahead and import. Okay. Also going to say from LangChain dot let me just import this. I'm going to say from LangChain dot chat dot chains. I'm going to go ahead and import the retrieval QAChain. Again, I'm also going to go and say from LangChain underscore OpenAI. I'm going to go ahead and import OpenAI embeddings right here. Okay. I'm also going to go ahead and import a couple of things more. So from LangChain, that's a lot of importing we are doing. Okay, so just bear with me. From LangChain dot vector stores, I'm going to close dot Neo4j Vector. I'm going to go ahead and import the from Neo4j Vector just like that. Okay, also going to say from LangChain dot prompts, I'm going to go ahead prompts. I'm going to go ahead and import the following. So I'm going to import a couple of things. So first I'm going to go ahead and import is the prompt template. I'm going to import the system message. I'm not going to use chat message. I'm also going to import the human message. So let me just get rid of this right here. Okay, that's all I want to import. Okay, make sure that you have the right environment selected right here. Okay, so once that's imported, now you're going to go ahead and create now our embeddings. Okay, so how do we go ahead and creating how do you go ahead creating this embedding? So I'm going to say Neo4j Neo4j underscore graph underscore vector underscore index is going to be equals to Neo4j vector dot from we're going to say from existing index, right? Sorry, from existing graph, because remember in the last videos we have this graph already created, right? So let me just pull up the graph and I'll be back recording. Yeah, so I have pulled up the graph here. You can see this is the graph that we created from the last video. You can see all the things. You have the different nodes right here: the category node, the customer node, the employee node, the order node, the supplier, the shipper. We have all those node properties in here. This is what you have done from last video, right? So yeah, that's basically it. So right, we have done this from the very first video until we have built the ETL pipeline to insert the data in here, right? So we're going to go ahead and use this existing graph. That's for this reason. That's why we're saying dot from existing graph, because you already have the graph already created. We're going to go ahead and specify the embeddings. And the embedding, you're going to say OpenAI embeddings. As I said, you can use any other embedding model that you want to. That's absolutely fine. There's no issue with that. You just use the model that you want to use. Okay, so I'm going to be using the default embedding model that OpenAI provides us. So good. So I'm going to just go ahead and simply say OpenAI embeddings, and I'm going to say API key is going to be os.get environment. I'm going to use our OpenAPI key right here. Oh, good. So if you're using any open source model, you just pass in the model as embeddings right here. Okay, so actually this is embedding and not embeddings. So my bad there. So once we have, we're going to say URL, and URL is going to be equals to, this is going to be the URL to our Neo4j instance. So get env, and you're going to say Neo4j URL right there. You're also going to go ahead and specify the username, which is our Neo4j username. And now we also need the password, which is going to be our Neo4j password as well. Okay, now we need to specify an index name. So what index do you want to create? So to create an index, you can just go ahead. You can go actually view the existing index. You can go ahead and simply say show indexes right here, and then and that is the semicolon right there. So let's execute this code, this Cypher code, and let's see. These are the existing index that you already have, right? So good. So now I'm going to create another index called employee index. Okay, so I had this index created whenever I was testing out something. So I'm going to go ahead and simply show you how to create it from scratch. But in your case, you might not have any index right here. Okay, so I'm going to go ahead and create an index again, right? I'm just showing you how to work because I've already done this on my own. That's why this indexes existed. I wish I deleted it before making the video, but anyway, I will just show you how to do it in case we are going to assume that you don't have the indexes on your end. Okay. Okay, so once you have that out of the way, let's go back in here. Okay, so in your case, that should be empty. So I'm going to call this index employee index. So employee there. Okay, so we're going to use this to store different employee information. So why am I specifying an index specifically for the employee details? So if I just go ahead and view one of the employee information, right, you can see this employee has a lot of text, right? So notes, has a lot of notes that you're going to create embeddings for. So these are the things that I want to be working with right here, right? So all this information, I want to create embeddings for all of them, right? So this is a lot of text, so we need embeddings for them. But if you just for something like a supplier, each supplier just has like a name, sorry, just hold on, this just has a name. It's very basic information. You really don't need to create a vector index for that. But because of an employee has a whole profile information, so sometimes you need to be able to search through this description of the employee. So that's why I'm going to go ahead and create an embedding specifically for the employees. Okay, so in your case, if you have labels or nodes that have different properties, a lot of text, then you might want to create embeddings for those. Okay, so once that's out of the way, I'm going to go ahead and specify now which text properties do I want to create. Text node underscore property, just like this. you're going to go ahead and specify the properties that you want to. So these are actually properties and not a property. So this is going to be a list of properties. Okay, so these properties basically are these things from here, right? These things right here. Okay, this is an employee, and these are the properties of that employee node. So country, last name, first name. You want to create an embeddings for all those. So just go ahead and specify all the things that you want to create embeddings for. So we can go ahead and say I'm going to create an address. Sorry, my bad there. So address, my bad. You can create one for city. You can create another one for let's say the title. Sorry, this is going to be the title. You can create another one for the email, another one for postal code, and again make sure that they're the same names as the ones in here, right? So yeah, so make sure just go ahead and go through in here and make sure that they're the same names in here. So postal code, that's why I'm specifying postal code, right? You can specify any of those properties that you want to create embeddings for is really fine. In this case, what the most important thing is probably the node, right, which I haven't even included yet. So it is just the node property. So if I go in here, because it's the one which has really a lot of text, right? These other ones you really don't need to have embeddings for them, but just when you just says create embeddings for them anyway. So once we have that done, say node city, we can say first and last names. Okay, so sorry, this is going to be first name, and also we're going to go ahead and have another one for last name. Okay, so first name, last name, sorry, let me just scroll down here. So first name, last name, this is actually a comma. First name, last name, you can specify the region if you want to. Okay, so this one will also be the region. Exactly. So once we have this done, we are good to go. So I'm going to go ahead and keep a comma and then pass in the last thing I want to pass, which is just the embedding node property. So this is going to be basically property, and this is going to be a string, and you're going to call it embedding, right? So you can see right now we don't have anything in here, any property called embedding, right? Nothing, no property called embedding. But once you create an embedding for that, then it's going to include the embedding property in there. Okay. Okay, awesome. So that's all we want to do in this case. So yeah, we're ready to go. So once we have this, let's execute this, and it's going to take a bit of time. Okay, we have an error here. It says existing missing right required positional argument node label. Okay, so let's take a look at this and let's see where we have missed the node label at. So we need to specify the node label, not here. So this is the index name is if you forgot the node label underscore label, and the node label we're going to say the node label is going to be, let's change the index to be with a small letter e, and let's change the node label to be employee, because you're working. The reason I'm saying employee is because in here you can see this node, its label is employee. That's what you're specifying in here, but the index name could be anything, but the node label must be one of these labels of your nodes, one of these, right? So if you want to create for category, sorry, for the supplier, would you have to use a supplier. If you want to create for embeddings for category, you have to use category node and specify the properties under the category nodes, right? Okay, that's all we need to do in here. So we are good to go. So index name could be anything you want. I'm just gonna say employee, and then we have everything. Okay, we are good to go. So I'm just going to go ahead and run this. So hopefully if you have no error in there, that should go ahead, create all the embeddings and then store them inside of. So if you see another label in, if I hover on this, you see another label in here called employee, which gonna have the employee information, right? Okay, good. So let's give this a bit of time to do to go ahead and create for us those embeddings. So make sure that your OpenAPI key and everything is loaded in here. It's just like from the last video, I just using basically the some notebook. Okay, so once that's done, I'm going to go in here and let's reload this cell. So I'm going to go ahead and run this one more time, and let's say pick one of these employees. So if I scroll down, you can now see, we should see embedding. You can see now the embedding, which is this name that is specified in here, right? This name right here is what comes in. You can see now embeddings, which is just the vector embeddings, the vector indexes. Awesome. Once we have that done, we are good to go. So let's look at now. Yeah, we have done the embeddings. Let's see what's next on the list. So what's next on the list is performing a similarity search using a Neo4j Vector Index. So how do we perform a similarity search? So to perform a similarity search, let me just go ahead and say result. I'm going to store the output of the similarity search in a variable called result. Is going to be equals to Neo4j graph, and you're going to say dot similarity search, and you're going to go in here and specify the different things. So I'm going to go ahead and say you're going to search for Andrew. Remember, Andrew was the, I think Andrew was the Andrew. Okay, Let me get the spelling right. Andrew, just like that. That's the spelling of Andrew, no? And then you're going to specify k equals to 1. So k is the number of documents you want to return, you want to be returned back. Basically, when you perform a similarity search, this is going to Andrew, the name Andrew is going to match some couple of documents. How many of those documents do you want back? And that's going to be k. So it's going to match a couple of documents, and they're going to be arranged in descending order according to the ones which are most similar. So the most similar ones will be on top. The list which don't have that much of a distance, that have a huge distance, are going to be at the bottom, right? So the closest ones are going to be on the top. So we're getting only the very first one of those. So run this, and let me just print here result, and let's see what we get back. So we get back one document, and it can give us information about Andrew, and Andrew is an employee. So let's search for an employee. Let's go ahead and look at employee information. Good right here. And let's see employee that's called Andrew. Let's show the relationship, because I remember Andrew used to be of the vice president or something like that, if I'm not mistaken. So let's see. Yeah, Andrew right here. So you can see it returns to us the information about Andrew. And Andrew is a vice president. He stays in, let's see, location. City is London, and all that information. Country is the USA. So if you read through here, you can see sales manager, his email, his postal code, first name, last name. So his last name is Ting Buchan. I don't know. Sorry for butchering that name. Anyway, yeah, you see that information right here. Andrew information, vice president, does sales and stuff like that. Yeah, so if it takes some time, you should be able to find the information in here. So let's see, employee ID of 5, photo, blah blah, and pass in the photo information, and then the photo ID, the countries in the UK. Okay, so I think there are many Andrews that match this. Don't think there's only one Andrew. This one's another guy. His name is not Andrew. Let's see another one right here. No Andrew. Another one right here. Not Andrew. Not Andrew. Not Andrew. Not Andrew. Not. Yeah, but none of this document matches Andrew, so it's this guy right here, right? So you can see all that information has been returned back to us. Okay, so let's see the different information right here and stuff like that. So Andrew University, sorry. Okay, so I think it's returning to us an employee with an ID of let's see, with an employee. Let me see, employee ID equals to 5, right? So let's try to get that information. See, so let's search right here. So instead of just manually doing this, we just write a cipher code. So match, we're going to say E, which is going to be an employee, where the employee ID is going to be equals to 5, and then you're going to go ahead and simply return that information. Return E. Let's close that off. So now that I have it, I'm going to go ahead and run the code, and let's see what we get back. So we have this information. This is the person's name. Let's see if it also matches Andrew. I think Andrew was not the name actually it matched. It matched something else, which was this right here. You sent Andrew University, right? That's what it matched. So I hope you guys, let me just zoom in a bit. I hope you guys can see that right there, right? So it matches Andrew University, right? And this is the first name, and that's the exact records that we have right here, right? So if you pick the more document, then it should return to you more information, right? And let's run this as well. And you can see we have another information right here, right? Yeah, so this is an employee with an employee ID of 1, and this is now the Andrew, who is the CEO that I was apparently looking for. So because I remember his name was Andrew, so let me change this to 1, and let's go back here, and let me run this one more time. And now this time again, we should now have Andrew as I think it was a sales guy. C, Nancy, and then another Andrew somewhere. Okay, I wonder where it's matched Andrew. Okay, probably there's an Andrew in one of these things that I don't want really to waste time with. But yeah, the more documents you specify, the more matches you get back, right? But you can see that you're not really focusing this on something really, like focusing on maybe the name of the employee is this much, right? Or something like that. And look at that later in the upcoming video, as we continue along. So let's actually print result. I want to get the very first one, and I'm going to do .meta data. Okay, let's run that, and let's see what we get back. So this is the employee information, so you can see it right here. Awesome. Okay, so once we have that done, we can go ahead and search, do other things. Okay, so just want to go in here and yeah. Okay, so let's move on, and I'm going to go ahead and you're going to go ahead and to see what's next on the list, and then what's next on the list is just a view of the. Okay, so forget about the title. I made an error right here. It's not actually the directory setup. It's actually uh, how all these things work, right? So just for now, we have been able to perform similarity search, which is this part of the whole RAG pipeline, which is this one right here. So we're currently here, right? So forget about this header. Okay, just my typo. Just I forgot. I picked it from another slide and forgot to modify it. So performing similarity search with metadata filters. So we can actually filter this basing on different information. So let me give you a use case. So let's say that we have many employees, right? Like in our database, right? We have a couple of employees here, right? So if I go ahead here, you can see we have different employees, right? Right? Different employees from different places, right? All these different employees. So let's say that you want to filter on an employee where the all basically want to get all the employees coming from the US. So let's say that we have multiple employees that have the same name Andrew. Let's say these are three different employees that have the same name Andrew. So one works in the US and another in the UK, and then the rest, the last one in Nairobi, Kenya, right? So imagine that you only want the Andrew from the US and not any other place. So how do you do that? So we have three different employees. All of them have the name of Andrew. One is in the US, one is in the UK, and then the last one is in Kenya. But you want only the Andrew from the US. How do you do that? How do you filter basing on that? So that's where metadata filtering comes into play, because the metadata right here is the US or the country information. And if you look here, we have a property called country, which tells us which country the person comes from. So we can use this to filter and get only the Andrew from the US, right? How do you do that? Let me just show you how to do that. So this is going to be metadata filtering using filtering with metadata. Okay, so I'm going to go ahead and simply store the result, the result of the filtering in a variable called results, and I'm going to say equals to, I'm going to say Neo4j. We're going to do a performance similarity search again, and then in here, I'm going to go ahead and specify the following. So instead of, we have covered this part so far, the keyword that you're looking for, the k value, and you're going to specify the filter. Let's return let's get rid of the k value for now. Let's specify the filter in here, and you're going to say filter equals to, and pass in a dictionary right here. So what do you want to filter by? In this case, the country, which is a property as well. So I want to filter by the country, right? So we're going to go ahead and say country, and we're going to say the country is going to be equals to the US, because we only want the Andrew from the US. Let me break this down into multiple lines so that I don't keep scrolling each time. So we want Andrew from the country US, and you're filtering in that information and returning the first two documents. So if I run this and I go ahead and do a result, and if I run this, we get back those two results, right? That's basically how you can filter based on certain information. Okay, let's now remove this k value and let's see what to get back. Let's see. Sorry, my bad. Okay, let's run that. Let's run this as well. So you can see you have multiple things. The similarity search matches multiple documents, but you're only picking the ones from the US. So if you look through this, you should see all the ones. They should have a metadata country property of a country which points to the USA. Okay, so if you scroll, you can see this is US. This is the US. Okay, now this is country. It says US country. Okay, let's try to see why this is happening. I didn't expect that to happen. So going to go ahead and bring this all up here. So result is going to be equals to Neo4j Vector Index dot similarity search. You're searching for not Andrew, but now you're searching for employee details. So basically, so we're passing the employee detail in here, but you're specifying where the country is in the US. Okay, so in this case, we got back many returns, which doesn't really take into the filter basically into account. So let's try to change this to be employee. So we specify the employee detail in here, and let's run this, and let's run this as well. Let's see what we get back. So I should get the ones. Okay, again in here, getting the countries being missed, but you can see the first two are coming from the US, so it didn't really limit that for some reason, right? So the filtering didn't really work in this case. That's a bit strange. I never encountered this, but the filtering didn't work in this specific case to some reason. Okay, I got everything right. So let's see. Okay, let's try to do this. Let's try to print the meta information out and let's see what we get back. So let's say for employee in results, for employee in result, I want to go ahead and print out the employee details. So I'm going to say cleaned underscore page underscore content is going to be equals to, you're going to go ahead and say create a dictionary right here, convert the input into dictionary line.split, and you're going to go ahead and say line.split, and you're going to go ahead and split this line. You're going to split it once, okay, and you're going to go ahead and do this. You're going to use a list comprehension. You're going to say for line in employee dot yeah, so basically that's what I want to do, employee dot page content. So this is going to be employee dot page content. So let me get rid of all this. Sometimes the autocomplete just confuses me. So I'm going to say dot page underscore content, and then finally we're going to split it into backslash lines. Okay, so once we have that, I'm going to go ahead and print this, and let's see what we get back if I'm getting the right information. Okay, so now you're getting this error right here. So let's go ahead and actually fix this error right here. So we are saying cleaned page content is going to be equals to a dictionary. You're creating a Python dictionary. You're saying line.split, split this, okay, split it once for line in employee.page content, and then you're going to say strip and not split. So it's going to be strip, just like that. And this strip doesn't take in any arguments in Python. So we're going to say split, and then finally we're going to go ahead and split the output now based on a new line character. Okay, let's run that. Now you can see you're getting back the information right here. All right, so this is just something that I got the output and cleaned it up. You just have to practice and find out how you can clean your data in your own case. Okay, so once we have this done, I'm going to go ahead and do the following. So I'm going to go ahead and simply print. I'm going to have an f string right here. Okay, the f string. Okay, so once I have this, I'm going to go ahead and do the following. So I'm going to go ahead and simply do the following. I'm going to say first name is going to be equals to, and then you're going to go ahead and simply print the first name. Also going to be cleared page content, and I'm going to first go ahead and simply use a get instead of this. So I'm going to say basically dot get, and I'm going to get first. Let me use a single quote right here. I'm going to get first name, right? And I hope you understand why I'm using an S string right here. Sorry, a single quote instead of a double quote, because I have used double quotes on the outside, right? So this is just some basic Python. So I've got the first name. You're going to get the last name, and you're going to go ahead and get the last name as well. You're going to go ahead and get the title, and you're also going to go ahead and get the country. Okay, so let me run that. You can see all the information right you have right here. Okay, so for country, I'm getting null for some reason, and that is because this is not how you get country information. So to get country information, you have to use employee.metadata.get country, just like this. And let me run this, and you can see what you get back right here. So you can see 2 are from the US, right, which are the US guys, and then 2 are also from the UK, which match the Andrew thing. Okay, and I'm getting an error. I'm getting none for this, the first one. So basically clean content dot get first name. Okay, so dot get first name, and let's see why I don't know, I'm getting that error. So let's see, clean page content, which is this one right here, dot get, and I'm getting the very first name. Okay, yeah, that sounds correct. So first name, yeah, that should be correct. For some reason I'm getting null back again. So let me just do this and print out cleared cleared page content, and let me see something. Okay, so let's see if you have first name in here, right? Yeah, first name is in here. Oh, so first name is actually just returning an empty string for all of them. So first name, yeah, first name. Let's see, first name. Yeah, so it's returning an empty string, and we have to find out why that's being an empty string. Okay, but for now we can just simply move on, and we just figure out why that was an empty string just in another section of the video. But yeah, that's basically how you can filter basing on a given metadata. So let me get rid of this right here, and you can run this code one more time, and that's basically the information that you get back. Okay, So once we have all this running, we are good to go. We are good to go right here. And the reason why I think the reason why we are not getting name as we're not getting the first name property because maybe of the way we split it right here. So sometimes the information can come in different formats. Sometimes you just have to investigate this into much deeper to understand the reason why that's happening. Okay, so but basically you can see all the other things work fine, right? So once we have this done, now let's go ahead and let's look what's next on the list right here. So next, and then we're going to performing metadata filtering using operators. Okay, let's take an example of this. So you can also use operators to filter data. For instance, suppose you want to retrieve a list of all employees, right? You want to get a list of all the employees who are not in the UK. So you want all the employees but are not in the UK. So you need like to negate a negator, right? If you ever did like discrete mathematics, you probably know what a negator is. If you don't, it's actually fine. But negator means basically negating something. Okay, I don't know a better way to explain, but making something opposite. So if it's true, if you negate true, you get false. If it's false, if you negate false, you get true. Something of that sort, right? So let's look into it, and the different operators that we can use. So we can go ahead and read this link right here, which is a LangChain official documentation. On Python, it shows you the different operators that you can use. Okay, so we're just going to go ahead and experiment with a bunch of these operators. Okay, so there are a lot of these operators, like I think like about 10 of these operators. Again, read the link, just go online and search for uh, metadata operators in LangChain. You get those operators, right? So now let's try to apply some of these right here. So when you say result is going to be equals to Neo4j similarity search, you're going to go ahead and simply pass in employee details. You're going to filter all the employees. So you're going to filter them based on country, and you're going to go ahead and pass in another dictionary. You're going to say passing now the operator. So use the dollar sign, and then you pass in the operator name. So not equal, NE stands for not equal. So let's say you want all the employees who are not from the UK, and let's run this. And you can go ahead and simply do result, and then let's run this. So we're going to return to us all the employees who are currently not from the UK. So if you look through the metadata and if you look for the country, you should see that these are not from the UK, they're all from the US, right? So it negates, that's a negator, right? Not equal, that's what NE stands for, not equal. So the different operators you can, there's greater than, there is less than or equal to, greater than or equals to, in, and especially like an in, like it's in a list, not in, between, like, and then like I without the being case sensitive, right? So that's basically the different types of operators. I just challenge you to go ahead and read through the different types of operators. So even if I copy this code, which you have right here, and let me just go ahead and run it one more time right here. And let's run this one more time so we can see now all these are not from the UK, they're all from US. Okay, awesome. Okay, so now the issue we have so far why the names are not showing is probably just here. So basically line.split, and you're splitting basing on this. Let me just remove this and let's see if this would work. So it's still the same issue. Just see this, and then for line in employee dot page content, because you're going to the employee. So in employee dot page content, right? In employee dot page content dot you're going to strip it, right? Dot page content, you're going to strip the page content, and then dot split basing on a /n. That's basically it. For some reason the name thing is, I have to investigate this much further, and if I have the answer to it, I'll add this the updates to the reposted on LinkedIn, on GitHub, where you can find the code. Okay, so once we have that out of the way, we can now proceed. Okay, so once we have that, just go ahead and look at what's next on the list, right? So I've looked at how to do filtering with different operators. And if you want to look at the operators, there are different types of these operators. Let me just write some of them here for you. So there is not equal, that's for not equal. There is less than, and there is less than or equal. There is greater than or equal. There is also greater than, and you can just, by this time you probably get the feel of it. There's a greater than, there is a in operator, there is a like operator, and there is a I like operator. The difference of these types of different type of these operators, right? So I just encourage you to go ahead, search things online, and you definitely come across this, right? So yeah, you can just search for these things online and you'll come across quite a number of them. Awesome. So once we have this out of the way, now let's move on and look at what's next on the list. So the next thing on the list is building a chatbot using Neo4j Vector Index. So that finally the most exciting part, right? So we have all the last 3 videos of 3 hours plus of content you have been doing, data preparing, ingestion, and all these pipelines, ETLs, and all this, right? So okay, finally, let's do something with chatbots. Okay, so now let's go ahead and do that right here now. So to build this chatbot, what I'm simply going to go ahead and do is pass in here basically a prompt. Right? We talk about prompting and prompt templates when you're working with introduction to LangChain for building a RAG graph application. So I'm not going to go ahead and explain to you what basically a prompt is, right? I'm just going to go ahead and copy the code and paste it in here. So I'll be back when I'll be back to recording once I have the code pasted in here. Again, if I paste anything in here that you don't understand, go back to the previous video, because anything I'm going to paste in here is from the previous video. Okay, so just go back to the previous video in case you don't understand this. Okay. Okay, so I'm back recording and you can see I have all the content pasted inside here. And if you're wondering where I got all this from, it's just you can find the repository for this series on GitHub, or you can also find this on my Medium article page. I also write Medium articles about this, right? So you can find it in one of those places. Okay, so all the links to that is going to be in the description of the video. So this is just a prompt right here, which is going to be retrieving the employee details. So your job is to use the provided Neo4j data to answer basically questions about their roles, their performance, experiences within the company. Use the following context to answer questions, be as detailed as possible, but don't make up any information that's not from the context. If you don't know the answer, simply say you don't know, and then provide in the context right here. Okay, so you can go ahead and say context, and then the context in there. Okay, so that's basically it. And once we have that out of the way, now you go ahead and simply create a employee prompt, system prompt, and you pass in the system prompt above, and then the only variable that's taking is context. Again, all this is just from the last video, so I'm not going to explain this in depth. And then human message, the template is you can provide details on, and then the user question. That's the only variable that's going to be taken in there. And then go ahead and create a list of messages, which is going to be the system message and the human message. Create basically an LLM using the chat OpenAI class. Okay, once you have that created, now you can go ahead and actually create basically a QA chain. So I'm going to go ahead and say QA underscore chain. Sorry, my bad. So QA underscore chain is going to be equals to, you're going to use the retrieval QA chain dot from underscore chain type, and you're going to go ahead and specify the following. So the first thing we need to go ahead and specify is the LLM, and the LLM is going to be equals to the LLM instance we created above on cell 33. We're going to go ahead and specify the retriever. The retriever is going to be equals to Neo4j and dot vector Neo4j underscore graph underscore vector underscore index. We're going to say dot as underscore retrieval. And I'm going to go ahead and specify the chain type. So the chain type, so there can be different chain types, right? So the chain types can be of different types. So let me just write for the different types of chain types you can have. So let me just write the stuff. The first one is stuff right here. So stuff basically takes all the user. The reason why we have different chain types, I've explained this in my previous videos and my previous articles where we have these different chain types. But let me just go over them briefly. So the first one is stuff. So what does stuff mean? Sometimes you might retrieve a lot of documents, right? Or retrieve maybe few documents, but the content of this document is so huge that it can fit within the context window of the LLM, right? So what stuffing does, it pushes all the content, all the retrieved document to fit within the context, the context window of the LLM. If it overflows, then that's an issue. Your program doesn't work. So the other chains you can use is called map reduce, which is this one, map underscore reduce. You can use that. You can also use refine chain if you want. You can also use map underscore re-rank. So I have explained all this in my previous videos, so I won't really go over them. You can just check the channel and there are videos on these different chain types. But you're going to use the stuff one, which is basically we're taking everything that all the documents you get back, and you're just trying to feed them to the LLM, right? So if in this case it happens to overflow the context window, then our program would have an issue. and there are different techniques around that, and you can use the different other chains. And again, read about them. I have articles and videos about them. Okay, so you can find them on Medium page, or you can find them on my YouTube page as well. Okay, so once we have that done, let's go ahead and simply update the prompt of this QA chain. So when you say QA underscore chain dot combined document chain dot LLM chain dot prompt is going to be equals to, now we're going to use the QA prompt. Then we say QA prompt. So I don't think we created the QA prompt right here. Oh yeah, I don't think we skipped the QA prompt creation. Let's see if I have it right here. So yeah, we skipped the QA prompt creation. So we created the one for the employee, right? We created the one for the human, and also we need to create one for the QA prompt. So we need to create it right here. So let me just go ahead and create one. You say QA underscore prompt is going to be equals to, you're going to say chat prompt template, and you're going to go ahead and specify the messages. It's going to be equals to the list of messages that we have. So messages, and I want to move, let me just do this right here. Get this code, cut it out, delete this cell, and let me move it below this so that we get access to these variable messages. And then we're going to go ahead and specify the input variables, and it's going to be the question and the context. That's all we want to do, and close this up and then run this. So let's see if I have this done. This is actually chat prompt template. So I have not imported this. I have to go all the way up here and then make sure I have that thing imported. This right here, which is just chat prompt template, and then run that. Okay, so once I have that running, once I have that imported rather, I'm going to go down here and then execute this one more time. Now it's going to go through. I'm going to say this is going to be equals to the prompt template, and then let's run this. Okay, let's say prompts. Let me just get, maybe I made a typo right here. Okay, this actually QA chain dot combine documents underscore chain dot prompt dot LLM chain dot prompt, and not prompts, and then run that, right? So yeah. Okay, once we have this down, now it's time to test it out. So now we have our QA chain, and you can use a QA chain to answer different questions. So you say QA underscore chain dot, and you're going to go and simply say dot invoke, and you're going to go and simply ask a question. You're going to pass in a query right here, and you can just go ahead and ask it a query, question. Say, what is the address of Andrew, right? One of the employees, so Andrew. That's it. And you're going to store, let me store this in a variable called response. So response is going to be equals this, and we can just okay, close this off, run this cell, and you can go ahead and actually print the response out. So response right there. Okay, now let's just print the response out. I just want to see what we get back before anything else. So print response, and you can see the response right here. So these are the results. Really sorry, but I don't have information provided to include details about employee Andrew. Okay, so yeah, it can't really find the information in this case, so that doesn't really work for us. So we don't get the information back on what is the address of Andrew. Okay, so sometimes you might need to try this a couple of times before you get, but yeah, because this is just still AI systems, and sometimes they don't really behave as you would love them to. So let me see. Yes, so let me just run this one more time, see if you can get the question. So it can still find information about who Andrew really is, right? So it's having difficulty finding information about who Andrew is, right? So yeah, let's try to ask a different question. Let's see. So sometimes this works, sometimes it doesn't, because this is really out of our control. But now let's actually ask a question. Let's see what other question we can ask it. So let's go back to the GraphRAG application, and let's see who is this guy. Let's ask a question about this. Run this. Let's run this and see. Hopefully, it provides us some answers on this, right? So it says, yeah, now we got an answer back. So the address of this guy is this, and then specify the address is in London. Okay. So let's see. Okay, the country is in UK. So this is the city is in London, and this is the address right here. So if you go back in here, you can see all that information has been answered correctly. So it just failed to pick up Andrew in this case. Okay, yeah, so that's basically how you can build a chatbot. And if you want to get the response, you can do .get and then get result, just like that. And if you run this, you can see the address of, okay, I don't want to pronounce this name because I'm obviously gonna butcher it anyway. So you can see this is the address right here. which is this from exactly from our knowledge graph, right? London, this. Okay, so it answered that question perfectly. So yeah, sometimes things work perfectly. Sometimes, okay, these are just AI systems, so they're not really deterministic sometimes. Okay, so once we have that result being printed out, now let's move on to what's needed. So that's basically how you can build a simple chatbot. Okay, let me not even move far. This is basically how you build a simple chatbot. So you can ask it different questions about different. Let's ask it questions about. Give me a short description of who this guy is. Okay. Uh, Let me just copy this. Let's say give me the profile details of, and then that guy, and we run this cell. Let's see what we get back in this time. So it should retrieve that document, pass it the LLM, and then basically generate an answer for us based on the profile. So you can see the name is this one, address correct, city location correct, region unknown. It's a sales representative based in the London. He works in sales, likely focuses on building relationships with clients, blah blah. Unfortunately, specific details on email address, postal code, and first name are not provided in this context. Right. So yeah, that's basically providing information. Please let me know if you have any other information. It works as a sales representative. So if you look in here, yeah, this guy works as a sales representative. Let me just scroll and find that information. So role, yeah, title is sales representative. Right. Awesome. So you can see it answers all that information, all that properly. So I think there was an issue when getting the first name. I'll investigate it and then see where we're probably making an error finding out the first name. Right. Yeah. Okay, that's basically it, and returning all that information, right? So yeah, that's basically how you can build a simple chatbot basing on your knowledge graph, right? Which is enriched with basically indexing. Okay, so you can read about the different chain types by using this link, and I'll share this link with you guys. So now let's move on to the last part, which is natural language to Cypher. Okay, natural language to Cypher. How does this really work? Okay, let me just let's take a look at this, right? So this is go back in here. You can see this diagram right here. So let's say that you have little Johnny right here. Little Johnny asks a question, right? Little Johnny is a human. Let's say speaks English. So yeah, uses English to ask the chatbot a question in English, right? The chatbot computers don't understand natural language, it is human languages. So how does a computer go ahead answering Johnny's question? So it takes what in this case in a GraphRAG system, what we simply do is convert the natural language, which is English, into Cypher code, which is programming code that can be executed on a Neo4j Graph database. We execute the code on Neo4j Graph database, basically converting our English into Cypher code. Talking to the database using that Cypher code, because that's the only language that the database Graph database understand. In this case, Neo4j. Once we retrieve the relevant information, we pass the information to LM saying, hey, the user asked this question, and this is the context that we want you to use to answer the question. The AI goes ahead and answers the question based on the retrieved information. So the AI now sends the final response to little Johnny. So now the AI answer is grounded on our knowledge graph database. It's not hallucinating or pulling information from the data it was trained on. Is actually using our own data from our Neo4j database to answer different questions. So the answer is grounded in our Neo4j database. Yeah, that's basically how it works. So now how do we convert? Now what you want to do is figuring out how to convert natural language to Cypher, right? Once you do that, the LangChain is going to go ahead and execute this and do all this other process for us automatically. And that's the power of having frameworks like LangChain. Okay, so now let's go ahead and see how we can do that. So you're going to be using something called GraphCypherQAChain from LangChain to be able to perform this action. Okay, so good. Let's go ahead and actually do this right here. So we need to bring a couple of imports right here. So I'm going to go and say I'm going to import OS. We have already OS imported. I'm going to say from LangChain LangChain underscore community dot graphs. I'm going to go ahead and import Neo4j graph like that. Yeah, I'm also going to say from LangChain dot chains. I'm going to go ahead and import GraphCypherQAChain, the Cypher QA chain that we talked about, right? Okay, that's all I need. Once I have these two things brought in, I'm going to go ahead and create a graph, connect to our graph database, and create an instance of it. So we're going to use this credentials right here. We're going to use our URL, our username, and our password to connect to our graph database. Okay. So once that goes through, we'll be connected to our Neo4j graph database, which is basically this graph database right here. So now that you're connected to it and we have stored in a variable called graph, we're going to say graph.refresh the schema to get the latest schema. So what does it mean, schema? Right? Schema basically is just the layout of the database. That's how I would say it in my own words. Now we can actually view that layout right here, right? The structure of that database. We can use epoch dot meta dot schema, just like that, and we call this function. So once we run this code, it's going to return to us a schema of our database. So all this, that's what this line does right here. It's basically getting the schema information and refreshing it to get the latest schema information. So it's going to get some information like this. Why do we need this? Okay, basically you want an LLM to write Cypher code on a database that it doesn't know. It can't, right? So you need to provide it information about, hey, I have this database and this is how the structure of the database look like. Now, basing on this structure, convert this natural language into a query, which is Cypher query that I can use to extract information from my database. So you have to write it the schema information. So this kind of schema, right? Okay, so that's what this basically does. Just refresh the schema and get the latest schema. Okay, so now that's we are done. We can move on ahead, and you can also visualize the schema if you want to. For those of you who are interested, you can just go ahead and do the following. So we're going to say call epoch dot db dot schema dot visualize, just like that, and we call this function. And once I run it, you can see now this is how the data looks like when it's visualized, right? Like this format. Okay. And I hope that makes sense. And just try to close this off. Yeah, so that's how the schema looks like. So we have employee, and employees can report themselves, like this, the CEO, which Andrew can report to himself. We have orders who are shipped by shippers. We have an order ordered by a customer. We have orders being processed by different employees. We have orders which include different products, and a product can be supplied by a given supplier, and a product can be part of a given category, right? That's basically our schema visualized. So it's just this schema information. Let me just scroll down here. This schema information, when it's visualized, it looks like this. Yeah. Okay. That's basically how this works. So once we have this now, let's go ahead and actually write Cypher code, basically to be able to extract information from this. So I have to now provide in some Cypher argument, basically a prompt template that tells the LLM to write Cypher code based on the schema. Again, this is prompt going to be a bit long, and these prompts are very long and detailed because of they have to include some few examples, which is something we're going to talk about just in a few. So let me just actually get the code and put it in here. Okay, so I've added in the code right in here, and I just got the code again from my, you can find this code on my Medium article, and you can also find it on GitHub repository on for this series, and the link is going to be in the description of the video. So we have just given the LLM a task. So generate Cypher query for a Neo4j graph database. Instructions: use the provided relationship types and properties in the schema, and this is, we are going to pass in the schema right here. And what is this schema? And this schema basically is this information. We're going to pass it in here. That's basically it. So pass the information in here, and then ask you to write a schema based on that. And then give it a bunch of information right here. You can pause the video and read through, or you can find this on GitHub repository. And in here, that's really something important I think we need to look at, which is just this example. So what does it mean, this example? What does it really mean? So I'm giving it an example right here. So this is a question: retrieve the total number of orders placed by each customer. So you're giving it an example of Cypher that it can write to retrieve all the orders placed by a given customer, right? By all customers in this case, right? So I also ask a question: list the top 5 products. Yeah, so I also have a bunch of information right here, and all this code is available. You can find the code on GitHub repository for this series, or you can also find it on my Medium page as well. And then there's something I would just skip over this, but you can pause the video and read it as well, because there's something I want us to talk about, which is these examples. But why are we giving it examples? Okay, so in this case, we're asking it a question: retrieve. This is the question right here, and this is the corresponding Cypher it needs to run in order to answer that question. This is another question right here. This is the Cypher it needs to run in order to answer that question. So you can go basically ask yourself a question, and then write the cipher for it. Make sure it works in Neo4j, right? So you copy the code, paste it over here. Once it works in Neo4j, you can now move it and into your actual code here. So you have the question that you thought of in your head, you write it down, you write cipher for it, and then you put in the cipher code in here, right? So you do that for a couple of more questions, and that's we have question, example cipher, question, example cipher, question, example cipher. So why are we doing this? This is a technique called few shot prompting, right? So this is a technique called what we call few shot prompting. Okay, so just ignore this slide. This is a technique called few shot prompting. Basically, give the LLM a bunch of examples that it can work with. So think of it like this. Let me just explain this to you in a very day-to-day, using a day-to-day example. So let's say that you have two people right here. We have little Johnny and we have Papa, who is the father of Johnny, right? Little Johnny. So Johnny wants to learn how to ride a bicycle. Like, I think this is a process we have all been through and you can relate, right? So imagine yourself as Papa. How will you go about teaching your little son Johnny to ride a bicycle? Like, how did your dad teach you how to ride a bicycle? Basically, just pause the video and think about it. But now imagine yourself as your dad, as a dad, and you have a kid, and the kid wants to learn how to ride a bicycle. What's the first thing, or what process would you follow to teach your kid how to ride a bicycle? In this case, little Johnny. How does Papa teach little Johnny how to ride a bicycle? Pause the video and think about it. I'll be right here waiting for you. Okay, so I hope you spent a bit of time thinking about it. Anyway, so let me just give you an example of what I thought of myself. So if I was Papa, I would jump on the bike and ride the bike around a few times, so that Johnny can have an idea of how it works. And then from there, I will have him hop on and then try to repeat the same process I just demonstrated, right? So but that's basically what you're doing right here. The LM wants to do something, answer a question. We provided an example of how to answer that question. So it's learning how to kind of like learn to answer our questions based on our schema. Right. So now from this example, you can know how to write cipher. We're not basically teaching it from scratch in this case, but it has an example, an idea of how our schema is, how to write in different queries against our schema and all that. Right. That's basically what you're trying to do. It's called few shot prompting. Okay, the different prompting techniques right here. We have a whole field called prompt engineering, right? This is really something completely separate on its own, right? But this is just a technique when you have prompt engineering, which is called few shot prompting. Provide this few example. There's also zero shot prompting. You don't provide it any example. Few shot prompting provided few examples, right? Okay. I hope now that clears a lot of things up and makes a lot of sense. But now, before we move on, I want us to talk about something really important. So we're having an AI write an LLM against our database. And this AI is taking instructions from a user to generate cipher that is being executed against our database. So let's say that you have a friend called Johnny. Okay, I know I'm using it too much, Johnny, but let's say you have a friend called Johnny, and you have built a chatbot and you gave it to Johnny, and Johnny somehow is a very malicious person. He likes breaking things down. So he goes in there and try to tell the chatbot to delete all the data in the database. Do you think ChatGPT or these open AI models, or basically open source model you're using, or basically any model out there, any AI model, you think it's gonna stop because the content says delete stuff? It's not going to stop the AI from not writing the query. So the AI will generate the query and execute the query anyway and delete stuff in your database. So that's really bad, because basically you're giving access and full permission to your database to a user through a chatbot. So if that user is really good at something we call prompt injection, he can inject malicious instructions to your chatbot and can cause your chatbot to delete information from your graph database. So how do we go about working around this process? One way you might think that, hey, just write in the prompt telling the AI not to update, not to delete, not to do this, not to do that. That might work to some extent, but with prompt engineering, it can be better. Like there's a way work around it. So just to be absolutely sure, because you can't really trust an AI, okay, at least at this point, at least when it comes to such a specific task. So what you would do in this case is simply, where we have Neo4j passwords, right? Our passwords and username and other stuff like that. So you can create another user and give it only read permission. So it can only read information from the database. You can't update, you can't delete, you can't add new information. It can only read information. So no matter what malicious prompt is trying to, people are trying to inject into it, it can't really have permission to execute those prompts. So if the user asks, it deletes all the stuff in the database, and you're using a user who has only read permissions to connect to that database, then the query won't go through. So the LM will definitely fail at doing that, right? So just keep that in mind. If you're doing something in production, make sure that you don't expose your private information. Okay. Awesome. So once we have that done, let's go ahead and run this. Okay, hopefully no errors. Fine. So now let's go create a Cypher. I'm going to call this one Cypher. Cypher underscore generation underscore prompt. And this is going to be equals to function. So we're going to use the prompt template. So prompt template. And you're going to go in and pass in the input variables. So you're going to pass in the question and the schema, because you have question right here. And we have schema as well right here. Right. So you're passing the question and the schema, and you're going to that's basically it. And then let's run this. Hopefully no errors. Awesome, no errors. So QA generation underscore template underscore str string. Right. So we're going to have the string right here. Okay, let me just get rid of this. Okay, let me just delete this one right here, and let's go in here. I want to do this. Okay. So let's say that let's ask a bunch of questions. You are an assistant. You are a data scientist working in a company that uses Neo4j Graph database. Basically, you can pass in any information basically at this point, right? Just instructing the LLM on what, like a system message, right? That's basically what you're trying to do right here. So make sure you pass in well detailed information. Your job is to Neo4j database, write Cypher blah blah query to answer different questions, the following questions. I'm going to go ahead and now specify to it what question we want it to answer, right? Right. So that's basically it. So that's once we have that, and then you're going to pass in question and the context. Okay. So this is going to be a bit long of a text. So I'm just going to go ahead and simply copy it from my Medium article right here. I have it already written, so we don't waste time there. So I'm going to copy this question. Let me just copy this part right here for now. Select all this, paste it right here, and let me select the remaining one here. Actually, I need to go ahead and fix this part right here. Okay, paste this one right here, and let me run that. Okay, so once we have that, now we're going to go ahead and create now the QA, just like that we have previously. So copy this, go in here, paste this. Okay, so this is the same thing that we have done in the last video, so it's nothing new. Just working with prompt templates in LangChain. Okay, so once we have this, now we can go ahead and use this information. Basically, this basically tells the LM to answer questions. So you are an assistant that takes in the result from a Neo4j Cypher query and forms a human readable response. The query results section contains the result of Cypher query that was generated based on a user's natural language question. The provided information is authoritative. You must never question it or use your internal knowledge to alter it. Make sure the question sounds like a response to the make sure your answer sounds like a response to the question, right? Okay, so that's it. And then you have the question. You have this one right here. You say if provided information is empty, respond by stating you don't know the answer. Empty information is indicated by this, and then in the information is not empty, you must provide an answer using the results from the Cypher query, right? So if the question involves time duration, assume the results are units of time of days unless otherwise, right? And yeah, this is just a bunch of information, and then you're gonna generate for your fun answer. So you can read through it. You can find the video. You can find the repository on LinkedIn. Sorry, the GitHub repository on GitHub, or you can find the article as well on Medium, right? All the links are gonna be in the description of the video. Okay, so let's go ahead and actually write some Cypher underscore. Okay, I'm having a lot of typos, right? So my mic is just in front of me, so sometimes it's difficult to type. So I'm going to say GraphChain. I'm going to say dot you're going to say dot from from LLM dot LLM, and you're going to go ahead and use it right here. So we're going to pass in the top k, right? You're going to pass in the top k, the top underscore k, the top k document that you want back. You're going to use that to be, let's say you want the top 10. You're going to go ahead and pass in our graph. In this case, our graph is just our graph instance that we have. You're also going to use verbose, and you're going to say verbose is going to be equals to true, which means you can see how this LM is working on the background. Validate Cypher, you're going to say that to be true as well, which means that LM is going to validate the Cypher before trying to execute the Cypher. Okay, and you're going to say QA underscore prompt. I'm trying to say the QA prompt, and the QA prompt is going to be equals to, and you're going to use the QA prompt generation prompt, and you're going to go ahead and use the Cypher. So the QA generation prompt is basically what is used to answer the user question, and it's this one right here, right? And then now the Cypher one is going to talk about the Cypher we talk about few shot prompting, right? Okay, so once we have that there, we're going to also go ahead and generate the QA. You can have, okay, my bad. Okay, you can have LLM, QA LLM. You can provide in different you can have one LLM for doing question answering. You can have another LLM for writing Cypher. So what I would typically advise you to do is that you have a much powerful model for writing Cypher, because the better the model, the better it can reason and the better it can answer something. So you can use something like GPT-4 or GPT-4. Let's say 4o underscore mini, just like that. So we have GPT-4 mini, which is more advanced than the GPT 3.5. So in the future, GPT 3.5 will be phased out. I had the announcement. So make sure that in case you're watching this and it's failing, make sure that you use something like, just go to OpenAI, Google the latest models and use one of them here as well. But in this case, this model is more advanced than this model. So this model is going to be writing the Cypher. So we need a bit of thinking power, right? So that's what this one does. This model here is much powerful. It can be used for writing the Cypher. And once the results are returned, GPT 3.5, which is a less powerful model than 4 mini, can be used to answer the question. Okay, so now also let's keep temperature to be 0. So temperature and 0. And then also here, go ahead and say temperature and also say for that to be 0 as well. So yeah, that's what we have. So once we have that, I'm going to go ahead and run the cell. So okay, good, we don't have any error. So let me just explain to you what each of this means. So top K specify the number of query results to indicate in the QA prompt, right? Number of document that we pass into a QA prompt. The graph, basically, this is just an instance of the Neo4j connection to the Neo4j database. And then verbose determines whether the intermediary steps performed by your chain are displayed or not. And then we have validate schema. This is just a boolean value which turns true or false. If it's true, then the schema will be validated before the code is executed and stuff like that. So because you're using an AI, there is this feature doesn't guarantee a valid schema query, but can fix straightforward syntax issues detectable through regular expression. So it can use something like regular expression to check if the syntax is correct. There's no guarantee, but at least having a loaf of bread is better than having none, right? So yeah, and then you have the QA prompt, which is templates used to answer questions. Cypher, which is we talk about the Cypher query, that's what is used to generate the ciphers. In this case, we use the few shot prompting technique. We have the Cypher LM, which is the LM that is going to be used to generate the Cypher code, which should be typically be a much more powerful model than the QA LLM, which is just used to answer the question, right? So once we have that, let's go ahead and ask it the questions, right? So question is going to be equals to, let's say, what is the most expensive product? What's the most expensive product? Okay, so that's our question to it. And now we're going to go ahead and generate a response. We're going to say .invoke, and we're going to pass in that question. And I'm going to go ahead and simply print that response once that goes through. Response. Okay, so run this and let's see what we get back. So the most expensive product is this one right here, Cote de Baye. I hope that's the right pronunciation, and this is the cost of it. So that's basically it, how it answered that question, right? And later on, I'm going to try to retrieve the cipher that you can use to see how it answered that question. So let's look at the cipher query. This is a cipher query it got. So let's copy this cipher query and let's try to execute it to see if it's actually giving us the right answer. So copy paste it in here. Let's execute this. Yeah, this is the most. So it's getting all the products and returning the product name as product name and the unit price as unit price, and it's ordering them by the unit price, which is this unit price, in a descending order, and it's getting only the first one. So that's returned to us the maximum, the most expensive product. So it's correct. And you can see, so the AI took our natural language. Basically, let me just go back in here. Took our natural language, which is the English, converted it into Cypher, executed the Cypher, got the relevant information, and used it to answer the question. Awesome, right? So you can see this is the question. This is the data you got back from the LM, and using this is passing this information into the QA prompt, and the QA prompt is using the QA LLM, which is ChatGPT 3.5, to answer that question, right? So that's how it all works. Okay, so we can test this even more, ask it more questions. Let's see. So let's repeat the same question again. Question is going to say, list the top 5 products with the highest unit price. Do you have unit price in here? I don't think you have a unit price. Let me go click on all the products and let's see if you have unit price. I have to expand this guy to see if I have a unit price. Yeah, unit price. Okay, so now that should work, and let's ask it let's get a response. Response, and let's try to invoke this and then print response back. Okay, let's see. So the top 5 products is the most, so you can see it turned to us the top 5 products, and you can also copy the cipher that it generated. So copy that and just go back in here, and it's gonna be very similar to this one actually. So let me paste it in here. So get all the products where the product name is this, the unit price is this, order by this, descend and get the first 5, right? Yeah, you're getting only the first one previously. Yeah, so that's basically it, and it should turn to us those products. Awesome. So it answered that question very well. Give me a more detailed. Let's ask it one more last question. Okay, so let's say question is going to be equals to, and say give me a more detailed give me more details on each shipper, as well as how many, as well as how many orders they have shipped. Okay, and let's go ahead and get a response. It's going to be equals this, and I'm going to invoke that, and let's run this and then print the response here. Okay, so let's run this and let's see. So yeah, this guy is asking to give us information about the shippers and how many orders they all shipped. Good, so you can see it ran to us the information right here, and you can go ahead and actually copy this cipher code. So I'm gonna go ahead and copy this cipher code. Go in here and let's execute the cipher code, and let's see. Let's read through this. We make sure that it doesn't generate any suspicious or malicious code. So match, get all the shippers which were shipped by this order, and then okay, everything sounds okay there. So let's run this. Awesome. So the federal shipper shipped a total of 76 of orders. Speedy Express shipped this amount of orders. United Package shipped 80 orders, right? And we get back all that in a well detailed format. Good. That's basically awesome how you can build this. And we have 3 shippers, right? So we don't have more than 3. So you turn to us 3, but because you have only 3 shippers, so match S, and S is a shipper. Okay, a shipper, and let's basically return S, and let's close off this and run this. So we have only 3 shippers: the United Packet, the Speedy shippers, and this. So yeah, that's why you go back to the record. So you can see that result is actually correct. So good. So our LLM now works perfectly fine. Everything works perfect. The cipher generation is working perfectly fine, right? Yes, guys. So that's basically how you can build a simple chatbot using basically build a RAG graph application using Neo4j, LangChain, and OpenAI, right? So yeah, that's all we have done. We have done really good stuff in this video. We have covered a lot in this video. So in the next video, we are going to go ahead and do something a bit more complicated. So we're going to go ahead and learn, we learned about agents, how to work with agents in the last video. Now we're going to go ahead and apply whatever we have learned in this video to building an agentic system that can be used to answer different questions. So we're going to be having an agent that can write cipher code, having an agent that can do vector searches and similarity searching and all that. So we're going to do that in the next video. So you can just take a look at, the picture of it right here. I didn't include it in the slides, but this is what we're doing in the next video. this one right here, right? You're going to have an AI agent that has access to two tools. So employee QA tool that can be used to answer employee question, which has the vector index information. And also we're going to have a general QA tool, which is the Cypher generation tool that can be used to write Cypher code, execute the Cypher code, and basically use that to answer user question, right? That's what we're covering in the next video. So guys, yeah, that's all for this video, and I hope you found it helpful and you have learned something really good in there. If you did, don't forget to like the video. That's one of the easiest way you can support the channel. Share this with all your friends, family, anyone who might be interested in it. Share this video with them. And if you want to support me further, you can follow me on other platforms, on Medium, on X. If you have any questions, you have any project ideas, you're working on something and you need a bit of consulting on it, you can always follow me on LinkedIn. I'm much faster to reply to you on LinkedIn than email. So if you have anything, just reach out to me through LinkedIn. And LinkedIn, you can find me at Prince Cramper. On Medium, where you can find this article again of this video as well. You can find that on Prince Cramper on Medium. You can follow me on Twitter as well at Prince_Cramper. You can also find me on LinkedIn at Prince Cramper, right? So yeah guys, again, if you have anything you need consultation on, you need to discuss any project, you have any idea that you want to work on, always feel free to reach out to me. Again, use LinkedIn. I'm much faster to reply to you on LinkedIn, and you can find me on LinkedIn at Prince Cramper. Thank you guys so much for watching, and see you in the next one. Keep safe.